Hello, Accelerated Math 6-7 students. Today we are going to be looking at our Lesson 9, Video number 9. Video number 9 is called From Ratio Tables, Equations, and Double Number Line Diagrams to Plots on a Coordinate Plane. Oh, you can't even see it. You got to speak up and tell me that. Okay, from ratio tables, equations, and double number line diagrams to the plots on a coordinate plane. And in my comp book, that's on page 26. Okay, so I'm going to turn in my comp book to page 26, and here I am on page 26, okay, from ratio tables, equations, and double number line diagrams to plots on a coordinate plane. I know the table is really long. The notes, however, are not, okay. So let's take a look at this so far, what we're going to be looking at. So our goal for today is, today we will learn how to turn a ratio into an ordered pair and plot it on a coordinate plane. So that's pretty easy, actually. All right. First thing that we need to know is there is a question that you're going to be focusing on. It says, why would you choose a graph to represent a ratio? So I want you to be thinking about that. I'll give you a hint. It has something to do with your eyeballs. Why would you choose a graph to represent a ratio? Okay. So the way we're going to discover this today is we are going to learn about a trip. Okay, and the trip that we're going to learn about is how long it takes a train to travel from Flagstaff to Los Angeles. Okay, and the reason why we need to travel to Los Angeles is to go to Disneyland, right? So we kind of want to know how long it takes. So if we were to ride a train and do that, the train leaves Flagstaff. I didn't put it up here, but the first place that they will make a pit stop is in Kingman. That's 100 miles away. Then they stop again in Needles, California, and that's 200 miles away. Barstow, California is 300 miles away, and then finally we get to Los Angeles, which is 400 miles away. Then, when you're turning around and coming back, they leave LA and go to Barstow, that's 100 miles. Then they stop again in Needles, it's 200 miles. Stop in Kingman, that's 300 miles. And then finally, 400 miles later, we're back in Flagstaff. Okay? And so basically, this is how the train travels. Something that you need to know, however, on this train is that to go from Flagstaff to Los Angeles all in one trip. So we start at Flagstaff, get to Los Angeles, go play at Disneyland for a little while. We're going to be really tired, and then come all the way back. Just the travel on the train takes 8 hours. Okay, but that means you're doing all of your travel. So you're going there and back all at the same time, and it takes 8 hours. All right. Now, you're probably sitting there going, why is she making us do this? Well, the reason that I'm making you do this is because I want you to use your information about ratio tables, equations, and double number lines to help me figure out how to put it on a coordinate plane. Okay? And in order to do that, we have to organize our information. So we know, the first question we want to know, or we actually do know, but I'm making you think about it, how long does it take to get to each place? So we know how many miles they are, but we don't necessarily know how long it takes to get to each one. And so that's our job today. Our job is to make a ratio table, a double number line, a graph, and an equation to figure out how long it takes to get to each place. All right, so, and we're going to keep in mind that when we're trying to figure out how long it takes to get to each place, that we're going to just say that it's a really safe trip and nothing's happening. So we aren't going to see any cows or have to stop for any reasons. We're just going to be able to go, go, go. All right, so the first thing that we need to do is, and I'm going to take us to there, and then I'm going to stop. All right, we're going to make a ratio table, which you guys already know how to do, okay? On this ratio table, time is the independent. Miles is the dependent, and the reason why is that if time doesn't go by, no miles go, right? You have to have time in order to go miles. So we know that in 8 hours, the train travels a total of 800 miles. Do you know why I said that? Because I told you right here to go from Flagstaff to Los Angeles and then to turn around and come home, it takes 8 hours. So we now know, well, that's a 400-mile distance out and a 400-mile distance back. So we know we add those two together and we get 800. So we know that it takes 8 hours to go 800 miles. Okay? So, 8 hours to go 800 miles. How can we fill in these? Interesting. That's kind of difficult. 8 hours, you travel 800 miles. Well, what if you only went 100 miles? Could we do that first? I know it's at the very bottom, but could we get there very easily? Well, the answer is yes, and that's exactly how I would do it. So we know, we know that time and miles, right? We know in 8 hours we can travel 800 miles. So if we want to find out how far 7, 6, 5, 4, 3, 2, 1 is down here, how do we get to 100 from 800? You can't see it. How do we get from 800 to 100? Well, I'm going to divide by 8. How about you guys? Divide by 8. What you do to one side, you have to do to the other. What is 800 divided by 8? 100. What is 8 divided by 8? 1. Okay, so that's kind of fun. So we could put a 1 clear down here. Now, if we put a 1 clear down there, how do we get from 1 to 200? That's right, multiply by 2. So it takes 2 hours to go 200 miles on a train. How about 3? 300. So how do we get from 100 to 300? We multiply by 3. What you do to one side, you have to do the other. 3. Are you starting to see a pattern? You should be. How do I get to 400 from 100? Times 4. What you do to one side, you have to do the other. Times 4. Okay, how do we get to 500? Times 5. What you do to one side, you have to do the other. Times 5 is 5. How about 600? You should be able to tell me now. 6 is correct. 700, 7 is correct. Nice job. Okay, so now we figured out the ratio table. Yes? So what do we know about the double number line then? The double number line is another way to write exactly what we already know. So what you need to write on this one is for 100 miles, right? And then this one would be 200 miles, and this one would be 300 miles, 400 miles, 500 miles, 600 miles, 700 miles, 800 miles. Awesome. So now you've written those in. What do we know about them? What did we find out from the ratio table already? Well, we know that 100 miles takes 1 hour. 200 takes 2, 300 takes 3, 400 takes 4, 500 takes 5, 600 takes 6, 700 takes 7, and 800 takes 8. Okay? And so that double number line is done. Pretty easy. Miles to time. Okay? Remember, we're talking about hours. Okay, so let's do our equation now. So it says the number of miles is blank the number of hours. So we're talking about miles. So we're going to say that the number of miles is 100 times, right? 100 times the number of hours. Does everybody see that? Then we're going to say the number of hours is, so we're doing the other way. What would it be, everybody? 1/100th, right? 1/100th the number of miles. Okay? So x is time, so we would write x equals, so we're trying to get the hours, x equals 100th times the miles, so y. Okay, and then if you know the miles, that miles equals 100 times the mile, so it would be 100x. That's how you would write the equation. Okay, it's a little bit difficult, but we'll get there. We'll just practice some more and more. All right, now we're going to figure out how to do ordered pairs. So an ordered pair is the exact location of a point on a graph. And an ordered pair has to be the x value first and then the y value, always. So in an ordered pair, the x value always comes first, then the y value. So if we're going to use our ratio table to make our ordered pairs, it's very simple. You put the x value first, which is 8. Then you put the y value, which is miles, which is 800. So I have 8, 800. What one would this be? 7, 700. 6, 600. 5, 500. 4, 400. 3, 300. 2, 200. And 1, 100. Now we have our ordered pairs. Okay, what if we didn't travel any time? How many miles would we go? 0. That's right. And this is an ordered pair also. You guys think that that looks like a boy. I know. Eyes, nose, I don't know. Don't go there. It's just called a 0. The 0, 0. Which this one has a name that you need to know. It's called the origin. You might want to write that down. It's really tiny in my notes, but you can fit it. Okay, so now we have our ordered pairs. So you're sitting there going, okay, I don't really know what I'm supposed to do. Yes, you do. So we know that the x value is hours and time, and the y value is miles. So now we have to build our graph, okay? And if we're looking at the graph, I kind of helped you already. The x value is always on the horizontal axis. So you might want to write that up here. Horizontal axis. And then the y value is always on the vertical axis. So hours goes on the bottom because it's the x, and miles goes on the y because it is vertical. So I already wrote in the miles, you have to do the hours. So basically we just go 1, 2, 3, 4, 5, 6, 7, looks like I fell off, but if it was there, it would be somewhere out here, okay? And so basically, you are using your ordered pair values on your graph. So notice these are all single digits, so those are all single digits. These are all hundreds digits, these are all hundreds digits. Do you see that? Okay, so here's how we plot it. It says 8, 800. Well, let's say 8 is about here, and then I go up to 800, which is about here, and I put a dot. That's how you plot it. Okay, 7, 700, so I go from 7 up to 700, which is about here. 6 to 600, which is about here, right? 5 to 500, which is here. 4 to 400, which is here. 3 to 300, which is here. 2 to 200, which is here. 1 to 100, which is here. And then 0 to 0, which is the origin, which you always have to do. And boys and girls, if my graph was perfect, that would be a straight line. But I didn't use a ruler or anything, and as you can tell, it's kind of squiggly. So if this was a perfect graph, it would be a straight line. Does it look kind of straight right now? Please say yes. Okay, I know it isn't, but you're kind of getting the idea. So this is it. That's the whole lesson. Now, the reason why I want to tell you that that's the whole lesson is I want you to go back to your question. Why would you choose to use a graph to represent a ratio? Why do you think? Look at it. Why do you think we should use a graph to represent our ratio? Does it give you a clear picture of what it looks like? Yeah. Are the dots on the graph? Let's do another graph, and I want you to see. Okay, so let's put one right here. Let's say 1 was right here. Let's say 2 was clear up here. Let's say 3 was down here. Let's say 4 was over here. Let's say 5 was here. Let's say 7 was here. And then you have to connect them. Look at this. Does this look like a ratio? It doesn't, because your line is crazy. Whereas if you had this one and we connected them, does it look semi like a straight line? The answer is yes. So what you're noticing is that if you have a true ratio with equivalent ratios on it, your graph will be a straight line. And if your graph is a straight line, it's telling you that you have equivalent ratios going. Plus, they're kind of fun, okay? And you have to know them because it's a 6th grade standard. All right. So I don't know if I left you, again, any work to do by yourself, but I think you're learning how to do a coordinate plane. We'll get some practice in class. All right, I'll see you later.